In the first part of the seminar, we said you can't have fractions and be simplified for square roots. So here's what we're going to do. If you have a fraction, just split it up. So you have the square root of a over the square root of b. Now you can't have a square root in the denominator. So what do you do if you have a square root in the denominator? Well, here's what you do. You multiply by the square root of that what's in the denominator. So whatever in the denominator, if I have a fraction, if it's a square root, I multiply by the square root. Now if I multiply the denominator by that, I have to multiply the numerator by the same thing. Now why did I do that? Well, because the square root of a times the square root of b, square root of a times the square root of b, well, that's the square root of ab. They're different. However, the square root of b squared, well, that's just b. I don't know why I put that square there. That was wrong. Just the square root of ab for the numerator. All over b. Now you don't have a square root in the denominator. So if you have something with the square root in the denominator, just multiply the numerator and denominator by that square root, and you'll get that answer. Now let's apply that to this problem. I've got the square root of 3n over the square root of 8. I think the first thing I'm going to do is I notice I can simplify the square root of 8. So let's simplify that. So I got the square root of 2 times the square root of 4. Now if you notice, you don't have to keep on making your factor tree because the square root of 4 is 2. So in other words, I got the square root of 3n over 2 radical 2. Because the square root of 4 is 2, and you got that extra square root of 2. Now you got a square root in the denominator. I don't care about the 2. Well, I should be careful. I don't care about this 2, the whole number. I care about the thing under the radical. You can't have the square root of 2 in the denominator. So I multiply the numerator by the square root of 2 and the denominator by the square root of 2. I don't have any like terms in the numerator, so if I take 3 times 2, I get the square root of 6n. All over my first 2, this 2, times the square root of 2 squared. Well, that turns out to be the square root of 6n over 2 times 2, which is 4. Now be careful. You cannot simplify this 6 and this 4 because this is underneath the square root. It's not actually 6. It's like 2 point something. Some irrational decimal that goes on forever. You can reduce whole numbers with whole numbers and radicals with radicals, but you can't reduce a radical with a whole number. And then here we have our concept summary. That is, you multiply the numerator and denominator by the square root. Now what happens if you have a square root polynomial in the denominator? Like let's say you have the square root of a plus b. We're going to multiply by something called the conjugate. The conjugate takes the second part and makes it opposite. So the conjugate of the square root of a plus the square root of b is the square root of a minus the square root of b. The conjugate of a plus the square root of b is a minus the square root of b. So whatever is in the denominator, that radical part, if you're adding or subtracting a radical, you take the opposite of it. Actually, if we take a look here, the first one is actually 0 plus the square root of a. So its conjugate would be the square root of a. Or should say 0 minus the square root of a. So we don't have to worry about that. So we just multiply numerator and denominator by its conjugate. Let's apply that. So I notice in the denominator, I'll do this in the next seminar.